excuse the allergy kind of thing. Something called antihistamine. I've taken allergy medicine in the past, but I'm not taking it this year. Trying to deal with it some other way, minimizing dust and things like that. It's seasonal allergies. I think it's seasonal allergies. Sounds like pneumonia and whatnot. Um, the heart pumps. Our heart pumps, and we have a pulse. You see the thumb. This is a thumb, and you can turn your hand almost in a half circle. So the pulse here in this area is called the radial pulse. There is a pulse somewhere here called the radial pulse. Now, if you look for it and you find it, you use your forefinger and middle finger to find it. I found mine, and you have to take the pulse of the patient. Now, where will the pulse be, in a vein or an artery? I can't answer that question. I think it's an artery because the artery takes blood away from the heart and the vein returns it. So by the time it's returning, the amount of pressure is somewhat at a deficit from when it leaves. But it's a closed system, and it's not a closed system because the volume of your blood can increase or decrease. I'm thinking aloud, I don't know. Now the aorta leaves out of the left ventricle, or the right ventricle. See, I used to know every part of the heart in biology. Anyway, so there are veins and arteries, and there are capillaries. Capillaries have no pulse, but they still transmit blood and nutrients. Capillaries are much smaller, I think, than the veins and the arteries. So now the concept of pressure in the pump, hardening the pump, and the pressure in the blood, circulating it through the body, and providing nutrients to the organs and cells. Is somewhat similar to pumping water through a pump and running a turbine to produce electricity. The electricity will be like the nutrients. That's why you circulate the blood for nutrients and to fight disease. And the the turbine will be um, like the lungs, and the seawater pressure would be like the heart. Now, the size of that pipe matters a lot. If it's less than 1 meter squared in area, cross-sectional area perpendicular to the normal, you get more gain, I think. So 1 meter square means that it is 3 feet by 3 feet, which is 9 square feet. Now that will be, so we're using cylindrical pipes. So if you make it like 0.25 meters or 0.33 meters, that's a 1 foot in diameter, I think. 1 meter squared cylinder will have the same area as a 1 meter by 1 meter square. And 1 meter by 1 meter square is 9 square feet, right? So a 1 meter square pipe has 9 square feet area. Now 2 pi is about 6.6, and then r square, 6.6 times what? I'm thinking it through my head, I'm not writing anything. You can change the subject of the formula. You have the area as 9 square feet or 1 meter square. What would the radius be? 2 pi r square is equal to area. Anyway, what happens is 1 meter is 3 feet. In the formula, pressure is equal to force over area. The area is in meter, not feet, because I'm using SI units. You can use other units too, but the SI unit I'm using, 1 meter is about 3 feet, but I'm doing it strictly in SI units. In physics, you use SI units. Engineering tables, you can use other units. I don't remember using 32.2 feet as G in physics. I remember using 9.8 meters per second square or 10 meters per second square. In Guyana, we didn't learn the 32.2 feet, if I remember correctly. So now the thing is, again, the heart pumps the blood to bring oxygen and nutrients to the organs. The heart itself is an organ. Now it is almost like deep water pressure turning a turbine to produce electricity. Now, I also said, we are going to stitch electricity using a single machine. So the Boeing manager, CEO says, we need to order some single machines, and we need to hire the engineers who can make those single machines stitch together electricity, right? Now, whether he's joking or just didn't understand it, you wouldn't know. You see what I'm saying?